So far, we only looked at Elm web apps that work by themselves in isolation. However, web apps need to talk to external APIs. For example, our shopping cart needs to submit an order and get data about the status from an external API. Here is the plan for this module. First, we'll look into the main challenges of getting data from an external API. Second, we'll look into how Elm web apps interact with external APIs with the help of commands. Third, we'll install and use the HTTP package to send data to an external API, then see how to handle answers from the API. Finally, we'll install and use the JSON package to decode the JSON responses from the external API. There are three main challenges when a web app talks to an API. The first challenge is about communication errors. Many things can go wrong when talking to an external API. The API might be temporarily down, or the network connection might break. The second challenge is about decoding data. Let's say our web app gets some JSON data from the API. Now, what if the data format changes? For example, a field was renamed or just removed. The web app needs to handle such errors without crashing or runtime errors. The third challenge is about Elm itself. Elm uses pure functions, which means those functions always return the same output for a certain input, which prevents a lot of bugs. However, real world is messy. For example, sending the same HTTP call a few times can return different results. Overall, Elm needs ways to handle these three challenges. The maybe type is one of the ways to handle these challenges. In Elm, all values must be present. By design, you cannot have null values sneaking around and crashing your web app. Still, sometimes a value may be missing. The maybe type is about offering a way to work with values that can be null. For example, while decoding data from an API, the web app might face some missing values in the JSON response. Furthermore, sometimes it's necessary to have a record with optional fields to reflect the structure of a JSON response. The maybe type is a special custom type in Elm. The key point about it is that it prevents null-related exceptions by forcing developers to handle potentially missing values explicitly to tell the compiler what to do when a value is null. The result type is about offering a way to handle operations that might fail. For example, if the API server is down, then the Elm web app should not crash. Instead, it should handle gracefully such scenario. For example, if the API server is down, then the Elm web app should not crash. Furthermore, if the web app gets some invalid JSON response, then the web app needs to prevent any runtime errors. Similarly to the maybe type, the result type is a special Elm custom type. The key point about the result type is that it prevents various runtime exceptions, not just null-related ones like the maybe type. The result type enforces the discipline of handling potential errors explicitly to avoid surprise crashes. Here are some code examples to illustrate the maybe and result custom types. This is the definition of maybe, which has two variants, just with a payload value or the nothing variant. Previously, we used the string to int function to convert a user input value to an actual integer. Since a user might enter a typo, such conversion might fail. Therefore, string to int returns a maybe int, which means it's either an actual integer or nothing if a valid value is missing. The definition of result also has two variants. Unlike maybe, both result variants have payloads. These payloads can have different types. For example, the validDigit function takes an integer and returns a result of string an integer. If the input is a valid digit, then it returns an OK with the integer payload. Otherwise, it returns an error with a string payload containing more details. Similar functions can handle calls to an external API to return OK or error payloads. Let's have a quick demo and add a status field to the model definition so that we can keep track of what happens when calling an external API to submit the shopping cart order. Also, we are going to refactor the code with the help of the Elm compiler so that the shopping cart still works after adding the new field to the model. Currently, model is a list of products. Let's turn it into a record that also has a status string, products and status string. Following this change, the Elm compiler turns red because of the new type mismatch errors. To navigate the errors, click the Go menu and notice the default shortcut, F8, to go to the next problem. The first problem is about a list map which needs only products. So add model.products and the problem is solved. Press F8 and do the same, model.products. Again, model.products, F8, model.products. This error is about inventory model. Control-click on inventory model to go to its definition. We don't need a status field for it, so let's set the type of inventory model to just a list of products. Press F8 again to go to the next problem, model.products, F8. In the update function, these two branches call change quantity. Let's modify change quantity so that it changes only the product field of the model. It should return a record with the model, then the pipe symbol, products, is equal to the rest of the expression. Save the file, the error seems to be fixed, so press F8 again. Add model products, F8, model products again. For the add to cart branch, we also need to return the full model. So let's do the same approach. Model, pipe, and update only products. Alright, press F8. Do the same here, model, pipe, and then just products. For the initial model, let's turn it into a record. Products, and then status, please add products and submit your order. Here it's model.products, F8 again, model.products. And there are no other errors. We fixed all errors and the compiler is now happy. Let's look at the next steps to start talking to an external API.